Imagine a world where the sun is no longer the giver of life, but a relentless furnace. The heat is rising and it's not stopping. Coastal cities aren't just flooding, they're being erased from the map. We've spent decades fearing the rods from God or a massive asteroid strike that hits the Earth's surface with the force of 1,000 nuclear bombs. But now, we're facing a threat that's even more certain. Total, global devastation caused by the very light that sustains us. For years, we've toyed with the idea of small steps, cutting emissions, planting forests, and hoping for the best. But that strategy is no longer enough. The concept has evolved into something far more radical. Instead of just fixing the Earth, we're looking to the stars. We're talking about a space sunshade, a massive, futuristic umbrella designed to dim the sun itself. This isn't just a single satellite. We're talking about a gargantuan fleet, a constellation of trillions of tiny, ultra-thin mirrors floating in the silent void of space. This multi-layered barrier is designed to intercept and deflect a portion of the sun's energy before it ever reaches our atmosphere. It's a project of such staggering scale that it makes every other engineering feat in human history look like child's play. But as the world races toward this futuristic shield, we have to ask, is this humanity's greatest savior? Or are we accidentally building the ultimate weapon of mass destruction? A tool that could cool a nation or freeze an entire continent into submission at the flick of a switch. The stakes couldn't be higher, and the clock is ticking. But to understand the true danger, we first have to dive deep into how this works. So why is this such a big deal now? Why have we gone from talking about planting trees to discussing building mega structures in the silent void of space? Because the truth is, we are no longer just dealing with a change in climate. We are looking at a total planetary collapse. For decades, the global strategy was to rely on international treaties and green energy to pull us back from the brink. But those systems were designed for a world that moved much slower. Today, the heat is accelerating faster than our most advanced models ever predicted. It's like a hypersonic missile heading straight for our civilization. Traditional, ground-based environmentalism simply cannot move fast enough to catch it. That speed could mean the difference between a successful defense and total devastation. It's not just a theoretical exercise anymore. The United States, along with other global superpowers, is racing to develop a solution that sounds like pure science fiction: the Planet Shield. This isn't your grandfather's weather satellite. We are looking at a multi-layered, next-generation defense system operating across the most critical frontier of all, deep space. This is designed to be America's future shield against the sun's fury. At the heart of this shield is a swarm. Imagine a cloud of technology, a constellation consisting of not just hundreds, but trillions of autonomous mirror-like flyers. We're talking about at least 10 trillion individual units. On the ground, massive electromagnetic railguns or advanced rocket systems would stand ready to fire these payloads into orbit, launch after launch, year after year. In specialized assembly plants, production lines would need to churn out thousands of these mirrors every single minute just to reach the required numbers for the constellation. The scale is almost impossible to wrap your head around. We are talking about launching millions of tons of high-tech material into the vacuum. The financial investment alone would be upwards of $10 to $20 trillion. To put that in perspective, it is like building a Great Wall of China in orbit, not made of stone, but of silicon and carbon fiber, stretched across thousands of miles of empty space. For the final stage, there's the promise of total, absolute control. Once this envisioned arsenal of mirrors is in place, the theory of climate management moves from passive defense to active intervention. This powerful system could potentially intercept and neutralize the sun's excess energy before it even touches our atmosphere. It provides something humanity has never had, a real-time solution to a global crisis. It's the ultimate dream of an integrated artificial intelligence managing the Earth's temperature. With the shield, we wouldn't just be surviving, we'd be managing. We could, in theory, adjust the temperature of the entire world like a thermostat in an office building. It creates a sense of profound, almost God-like security. The idea that no matter how much damage we've done, we can just dim the lights, and everything will be fine. It's the ultimate reassurance in an age of total anxiety. We feel safe. We feel like we've finally conquered the star that created us. But let's dive deep down into how this actually works. How do you station a trillion tiny mirrors 1.5 million kilometers away and make sure they don't just drift away or burn up? The answer lies in a tiny, invisible island in space known as the L1 point. But how do we actually pull this off? How do you park a trillion-piece jigsaw puzzle in the middle of a gravitational tug of war and expect it to stay there? To understand the sheer brilliance of the planet shield, we have to look at the unique physics of our solar system. The foundation of this entire system rests on a very specific, invisible coordinate in deep space known as the L1 Lagrange point. Located about 1.5 million kilometers from Earth, directly between us and the Sun, the L1 point is a gravitational sweet spot. It is the exact location where the massive pull of the Sun is perfectly cancelled out by the gravity of the Earth. In this tiny island of stability, an object can sit relatively motionless with very little fuel. This is the ultimate high ground, the strategic boost phase, for intercepting solar energy before it ever touches our atmosphere. While traditional satellites struggle to maintain their orbits closer to Earth, objects at L1 enjoy a 360-degree, unobstructed view of the incoming threat. But we aren't just sending up one giant mirror. The envisioned arsenal of the planet shield consists of trillions of autonomous, ultra-thin flyers. Each one is a marvel of military-grade engineering, thinner than a strand of human hair, and designed to act as a precision-guided interceptor for light. The goal here isn't to plunge the Earth into a permanent winter. That would be catastrophic. Instead, the system is smart enough to distinguish between the light we need and the excess energy that's killing us. By deflecting just 1 to 2% of the total solar radiation, we can effectively dial back the Earth's temperature to pre-industrial levels. The process of getting these trillions of flyers into position requires a radical shift in how we think about space travel. Traditional chemical rockets are far too limited by their fuel capacity and launch windows. To build a multi-layered shield of this magnitude, we need the speed and efficiency of directed kinetic energy. Imagine massive electromagnetic railguns, either stationed in high-altitude deserts or, more effectively, on the surface of the moon. These railguns use kinetic energy to accelerate payloads to extraordinary velocities, launching swarms of mirrors into the vacuum with no need for explosives or liquid fuel. Once these flyers reach the L1 point, the integrated artificial intelligence goes to work. Each individual mirror is equipped with advanced sensors and tiny reflective sails. This vast network doesn't just sit there, it maneuvers. The AI instantly analyzes streams of data from solar weather stations, calculating the exact angle needed to deflect the most intense launch plumes of solar heat. If a solar flare is detected, the constellation can react nearly instantaneously, adjusting its trajectory to protect the most vulnerable regions of the globe. This ability to continuously track and manage solar input from space provides an almost immediate real-time picture. Unlike ground-based efforts like carbon capture or reforestation, which can take decades to show even the slightest results, the impact of the solar shield is near instantaneous. The moment the flyers deploy their sails and move into position, the energy hitting the Earth drops. It is a specialized precision weapon against global warming. Modern science has shown that we don't need to change the entire planet to save it, we just need to change the math of the energy balance. Because light travels at the speed of light, the engagement with solar heat is immediate. This allows for rapid targeting of specific latitudes. If the Arctic is melting too fast, the AI can maneuver the swarm to provide a mobile and flexible layer of protection over the poles. It is a truly next-generation shield, providing a level of security that was once thought to be impossible. By targeting the problem at its source 1.5 million kilometers away, the system dramatically boosts the odds of a successful planetary defense. It stops the threat before it even enters the atmosphere, potentially neutralizing the most advanced climate threats originating from any corner of the sun. In essence, the solar shield delivers powerful, targeted protection without the lingering consequences of traditional geoengineering. It is the ultimate dream of modern engineering, a mobile, flexible, and intelligent barrier. Everything sounds perfect on paper. The math checks out, the technology is within our reach, and the results would be world-changing. But as we've seen with every massive leap in technology, there is always a catch. The golden dome of the climate isn't just a shield, it is a delicate, high-stakes gamble. What happens when the most powerful system ever built by human hands faces the one thing we can't control? Reality. Because as impressive as this shield might be, it is also incredibly fragile. Everything we've built, the trillions of mirrors, the AI, the perfect temperature, rests on a knife's edge. And if that edge slips, the consequences won't just be a financial loss. It could be the end of everything. Let's take a look into the dark side of this futuristic shield. But let's get real for a moment. Despite the futuristic appeal of a solar shield, the financial and technical challenges are absolutely staggering. Imagine trying to maintain a swarm of trillions of mirrors, each one as fragile as a soap bubble, stationed in the most hostile environment known to man. The cost isn't just in the launch, it's in the upkeep. We are talking about an annual bill in the hundreds of billions, potentially more than the entire US defense budget. Each individual flyer might be cheap, but at the scale of trillions, the price tag becomes more astronomical than the orbit itself. It makes traditional infrastructure, or even a naval carrier group, look like a bargain. And then there is the physical reality of space. Our sun is a violent, unpredictable reactor. It doesn't just sit there, it burps out massive launch plumes of radiation and charged particles. A single, powerful solar flare, a directed energy burst from the sun itself, could strike the L1 point with devastating force. Because these mirrors are designed to be ultra-lightweight, A solar storm could physically blow the entire constellation out of position or fry the integrated circuits of the AI control system in an instant. This intense heating or radiation could disable or destroy the shield by causing structural damage or interfering with the flight control systems. Because light travels at the speed of light, the engagement is near instantaneous, but so is the failure. One bad day on the sun, and our trillion-dollar shield becomes nothing more than expensive space junk. But the truly terrifying aspect of the solar shield involves a concept called termination shock. This is the ultimate twist in our story. Think of it as a kinetic weapon aimed at the entire planet. Once the shield is in place, the Earth's natural systems stop trying to compensate for the heat. We become addicted to the artificial shadow. If that shadow ever disappears, whether through a technical glitch, a coordinated cyber attack, or simply because the money runs out, the consequences would be near instantaneous. The temperature wouldn't just creep up, it would skyrocket. We are talking about a global heat spike of 3 to 5 degrees in just a few short years. It would be like a giant meteor crashing down on our climate. Ecosystems would shatter, agriculture would vanish. It would be a total devastation of the biosphere, and importantly, unlike a nuclear strike, there would be no radioactive fallout, just a silent, searing heat that kills everything in its path. And we cannot ignore the advantage this gives to whoever holds the remote control. The deployment of such a system could spark a new arms race in space as rival nations realize that the solar shield isn't just a shield, it's a precision weapon. If a single nation controls the mirrors, they don't just protect themselves, they decide who gets to have a harvest and who gets a drought. By slightly adjusting the trajectory of the swarm, a defender could potentially intercept the giving light of a rival superpower, effectively burrowing deep into their economy without ever crossing a border. It delivers powerful, targeted strikes against a nation's food supply without the consequences of international law. Nuclear bombs are weapons of mass destruction meant to devastate cities, but the solar shield is a weapon of mass starvation meant to devastate empires. When comparing the two, the advantage of the shield lies in its pinpoint accuracy and psychological impact. It's the ultimate specialized tool for the entire world's climate. In essence, the solar shield provides a next-generation defense, but it also creates an unparalleled level of global insecurity. If successful, it secures America's future, but at the cost of turning the entire sky into a loaded gun. But what about the other superpowers? If the US builds a golden dome in space to control the sun, do you really think China and Russia will just sit back and watch? Their response might be even more unpredictable than the climate itself. But while the United States and the West continue to debate the ethics and the legalities of a global solar shield, other superpowers are not waiting for a seat at the table. China, Russia, and India are already active participants in a very different kind of race, developing localized, covert Geo-engineering technologies such as stratospheric aerosol injection. This sophisticated approach enables a nation to place reflective particles into a high-altitude spray, effectively de-orbiting the heat over their own territory. But the process doesn't stop there. Once these particles are in the atmosphere, they have the ability to maneuver the weather, adjusting the trajectory of global wind patterns. This maneuverability allows a nation to approach the climate from virtually any direction, including unexpected vectors such as the South Pole, areas far less protected by traditional environmental monitoring systems. When the impact reaches a designated point, it creates a terminal phase for the target nation's agriculture. In the final moments before a harvest, a sudden, engineered drought or a redirected storm can move at extremely high speeds, making it significantly more difficult for a country to protect its food security. Because the atmospheric entry of these weather patterns is so unpredictable, existing international treaties, which were designed for a much simpler world, face a major challenge in countering this threat. We are entering an era of weather warfare. You no longer need a nuclear warhead to destroy an empire, you just need to steal its reign. We also make original engineering and geopolitical content like this every week, so please subscribe and hit the notification bell for more videos. When the sky becomes a battlefield, no one can escape. The race to control the sun has only just begun.